Hey, good morning, guys. Assalamu alaikum. Welcome back to Inspired Teens, grade 12 mathematics, where in today's lesson, we are going to be starting trigonometry. Okay. So before we begin, can you guys please confirm that you guys can hear me clearly and that you guys can see my screen and that the audio is okay? Hey, good morning, guys. Okay, perfect. Thank you. Okay, everything seems to be fine. Okay, then let us begin. Okay, so we are going to start from the basics. So we're basically going to do like revision of everything you need to know. And then eventually we're going to get into the more complicated stuff. Okay, so let's have a look at this triangle, which is the first thing we're going to start with. Okay, a 90-degree triangle. So a 90-degree triangle is basically a triangle irrespective of its orientation that has a one single 90-degree angle. So here we have a perpendicular angle, okay, 90 degrees in this triangle. And now within this triangle, okay, we've allocated another angle as theta, okay, and always opposite to the 90-degree angle is the side which we refer to as the hypotenuse, okay. And then whichever angle we work with, let's just say we work with theta, we'll give another angle here, alpha. So if we are working with theta, okay, then opposite to theta is known as the opposite, and right next to or adjacent to theta is known as the adjacent. Okay, so that's how we figure that out. Opposite to the 90 degrees is hypotenuse, opposite to theta is opposite, and adjacent to theta is adjacent. Again, if we work with alpha, opposite the 90 degrees is still the hypotenuse, but in that case, opposite alpha, this would be regarded as opposite, and then this would be regarded as the adjacent side. Okay, so just keep that in mind. Okay, so we also have our trigonometric ratios that we form, being sine theta, cos theta, and tangent theta, right? So sine, cos, and tan. And for each, there's actually this little thing that helps us remember it. SOHCAHTOA. Okay. And all that reminds us is of sine being opposite over hypotenuse, cos, okay, being adjacent over hypotenuse, and tangent being opposite over adjacent. So these give us our trigonometric ratios for sine, cos, and tan. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And yes, we're working with the sides. Just keep that in mind. When we talk about opposite, we're talking about the length of the side. We're talking about the length of the side. Okay, so let's just do it quickly in terms of random other variables. So we're going to do it in terms of Q, R, and S. Okay, so sine theta, cos theta, and tangent theta. So let's have a look at this triangle. Here is our 90-degree angle. Okay, and here is theta. So we're going to give the ratios in terms of Q, R, and S, RQS. Okay, for each one, sine, cos, and tan. So let's look at sine theta. Sine theta is opposite over hypotenuse. So opposite is going to be opposite theta. Hypotenuse is always opposite the 90. So it's going to be opposite over hypotenuse. It's going to be equal to S over Q. Let's talk about cos theta. Cos theta is going to be adjacent over hypotenuse. So hypotenuse is still Q. Okay. The adjacent is what's next to theta, the side that's next to that angle. Okay, the side that's next to that angle theta, and that is R. So it becomes adjacent over hypotenuse becomes R over Q. Then we talk about tangent. Tangent is opposite over adjacent. Opposite to theta is S. Adjacent to theta is R. So it's going to be S over R. Okay, and that's the value of tangent theta and the value of cos theta and the value of sine theta, okay, in terms of variables. Okay, let's look at it on a Cartesian plane. Okay, so if we have to just put the same triangle on a Cartesian plane, refer to this as the X value, this is the y value, and r as our hypotenuse. Okay, then it would be the same thing. Theta is from 0 degrees. Okay, so opposite over hypotenuse is y over r. Adjacent of hypotenuse is x over r. Okay, and opposite over adjacent is y over x. Just like that. Okay, so just keep that in mind. Yeah, so if you'd like to use these variables, maybe some of you have learned these variables, especially when we learn how to do Cartesian plane questions, that's perfectly fine. However, you don't have to. You can still use opposite over hypotenuse and adjacent over hypotenuse and opposite over adjacent. It really doesn't matter. It's just expressed differently, and they use x and y because of the x and y coordinates on a Cartesian plane. Okay, so that's done and over with. Let's talk about our cast diagram. So the cast diagram is really important. Let me just get my notes 1 second. Okay. Okay, so let's have a look at our basic cast diagram. Okay, and it shows this little line tells us that it shows the quadrants where each trig ratio is positive. Okay, so we have a Cartesian plane essentially drawn up here. Okay, two sets of axes, a horizontal and a vertical axis. Okay, and we have it separated into 4 different quadrants. Okay, 1, 2, 3, 4, and that's the order in which we label it as well. Okay, 1, 2, 3, 4. So the first one is top right, and then we go in a anti-clockwise direction. Okay, so in the first quadrant, okay, and then also, why is it called the cast diagram? Okay, it's called the cast diagram because of the different quadrants. It helps us to remember it. Shucks. Okay, it helps us to remember it. CAST. Okay, alternatively, because this is in the first quadrant and then second and third and fourth, if you want to learn it like that, okay, instead of starting from the fourth quadrant, which is slightly weird, you can just learn ASTC. Okay, all students take CAT. All students take CAT, or there's many other ones maybe some of you have learned. Okay, so yeah, it's actually probably better to learn it in that way, so you know it from the first quadrant instead of like from the fourth quadrant. Okay, and basically what it means is in the first one here, it says here all are positive. Okay, meaning sine, cos, and tangent. Okay, these are all positive. These are all positive in the first quadrant. Okay, however, in the second quadrant, it's called, we have S for it because only sine is positive. Okay, while cos and tan in the second quadrant are both negative. Then we talk about the third quadrant where it says only tangent is positive. So since only tangent is positive, sine is negative and cos is negative. Then we move over to the fourth quadrant where it says cos is positive, and where cos is, it's only cos, by the way, only cos is positive, then sine would be negative as well as tangent. Tangent is also going to be negative. Okay, and on our diagram, we also have the angles given, okay, in degrees. So it starts off at 0. Okay, we start off here at 0, we go all the way to 90, go all the way to 180, go all the way to 270, and eventually back to 360. Okay, and yeah, 0 and 360, they essentially are at the same point. Okay, so keep that in mind. 0 and 360, they are essentially at the same point. Okay, another thing to note, you will notice that, like, for example, when we are doing reduction, okay, when we are doing reduction, we deal with certain reduction angles. For example, reduction gives us angles such like 90 minus, or certain reductions like 180 plus, 360 minus, and that may be familiar to you. Okay, it should be. So how do we attain those, or how do we determine which quadrants those are in? That's really simple. Because, for example, just say we're dealing with 0 plus or 360 plus. That's now going to be above it. It's going to be more than it. So it needs to be, it's in the first quadrant. Okay. What else is in the first quadrant is 90 minus. 90 minus is in the first quadrant. 90 plus would be in the second quadrant. Okay, because it's like more than 90 going towards 180, less than 90 going towards 0. Okay, 90 minus first quadrant, 90 plus second quadrant, and the pattern continues. So 180 minus there, 180 plus there. So 180 minus, you are in the second quadrant. 180 plus, you are in the third quadrant. 270 minus, you're in the third quadrant. 270 plus, you're in the fourth quadrant. Okay, so I hope that makes sense and we're all on the same page. Okay, so that's important. Okay, and one more, 360 minus is in the fourth quadrant as well. Okay, so let's move on to reduction, right? We already discussed a little bit, like to say that these are reductions. Okay, so how do we solve for reduction? How do we reduce an angle? Okay, so it's really simple. And we're going to start off with this example of sine 180 minus theta. So the key thing is to identify the reduction angle itself. The reduction angle itself is 180 minus. Okay, so you'll see it's always attached with the sign. Your actual angle should always be positive. Okay, 180 minus. Okay, so 180, the value of 180 is actually positive. It's not negative 180 minus. It's positive 180 minus. Okay, now we have to determine 180 minus is in which quadrant. Okay, and that comes back to our understanding of the cast diagram and these little plus minuses. So 180 minus, we can see that it is in the second quadrant, sorry. And in the second quadrant, only sign is positive. Okay, so keep that in mind. So what you can do each time is to just draw a little cast diagram like that. So it can help you remember and reference to this little diagram to see, okay, which quadrant am I in and which trig ratio is actually positive in that quadrant. Okay, so 180 minus, we said it's in the second quadrant and sign is positive. Okay, so this helps us to determine for our answer when we are reducing, what's our mathematical sign, meaning is it plus or minus? So we have a plus here. Then how do you reduce? It's really simple. For now, okay, just for the simple ones, you write down that trigonometric ratio. So we have sine, and whatever the second angle is, you just write it out. So this becomes positive sine theta. Sine theta comes from there. Okay, so let's do another example to better our understanding. So we have cos 180 plus q. Okay. Now, again, that's why I've drawn my little diagram. You can have a little cos diagram in paper 2 on every single page. It doesn't really matter. Okay. It's just to help you. Okay. To reference to it so that you don't have to sit and think. You just look there and you know the answer. Okay. If it helps. So then you ask yourself, which quadrant is 180 plus in? So 180 plus, that's going to be, sorry, this is supposed to be C, I think. No. What cast diagram did I draw? Okay, so 180 plus is actually in the third quadrant where only tangent is positive. So since only tangent is positive in that quadrant, and we need to reduce with 180 plus, our mathematical sign is going to be a negative. Thereafter, I'm just going to copy. Again, for now, we keep the trigonometric ratio the same, and whatever the second angle is, that becomes the answer. So this becomes cos q. Negative cos q. Okay, the reduction angle, you've reduced it, so it disappears. 180 plus, third quadrant. That's where only tangent is positive, therefore cos is negative, and we have negative cos q. Let's look at this one. Tangent 360 minus 60. Now, you might think you should just simplify and get tangent 300. Okay, because 360 minus 60 is 300. However, okay, we don't know the value if you couldn't use a calculator. for certain questions. We don't know the value of tangent 300. So we opt to reduce. Okay. So how do we reduce? 360 minus 60, same process. We take our little cast diagram. And we determine, okay, 360 minus is in which quadrant? That would definitely be in the fourth quadrant. Since it is in the fourth quadrant, okay, our sign would be negative because it's tangent and only cos is positive in the fourth quadrant, so it becomes negative. That comes from 360 minus. Thereafter, the reduction angle falls away and we're left with tangent 60. Okay, now tangent 60, I know the value of. Tangent 60 is equal to root 3. So this final answer is going to be equal to negative root 3. Whereas if you did it the other way, you wouldn't get root 3. Okay, so excuse me. So that's how we reduce that. Okay, and I hope that makes sense. So those are just simple reduction questions. Now let's talk about some rules because there are quite a bit of exceptions and rules that we have to follow. Okay, we don't just reduce every single question like this. Okay. And the first ruling we're going to learn is with regards to 90/270. Okay, using 90 or 270. So when it comes to, so this is using 90 or 270 as a reduction angle, by the way. So when it comes to using sine and cos with 90 or 270, if you are reducing sine or cos with 90 or 270, then sine changes to cos or cos changes to sine. Okay, so just keep that in mind. We're going to do an example. But when you're working with 90 or 270, I know maybe sometimes certain teachers maybe tell you to stay away from using 90 and 270, but you don't have to, all right? You can, it just works exactly, sorry, just 270 normally, but it works exactly like 90. Okay, don't be scared of 270, especially for sine and cos, it works exactly like 90. So again, if reducing sine or cos with 90 or 270, then sine changes to cos or cos changes to sine. Let's look at the ruling with regards to tan. With regards to tan, we don't use 90 or 270. Let's change this actually. I should say we don't reduce. Okay, because we don't reduce with okay, you don't reduce with 90 or 270. Cool, hope that makes sense. Let's do some examples. So we have sine 90 plus theta, okay, and in this case, right, the first thing we should actually note, okay, is that we have sine 90. Okay, we have sine and it's being reduced with 90. That's the first thing we should know. Okay, and we remember that when working with sine or cos and 90 or 270, if reducing sine or cos with 90 or 270, then sine changes to cos and cos changes to sine. So let's do a practical example of how that works, right? So that's the first thing we should notice, sine 90, and understand the ruling behind it. Then we note, okay, that it's 90 plus. And again, our little cast diagram, okay, tells us that 90 plus is in the second quadrant. In the second quadrant, only sine is positive, okay? So then you will write a positive because sine 90 plus, so we're working with sine, 90 plus is in the second quadrant, sine is positive in the second quadrant, so it becomes positive. However, our final answer, or when we reduce, we're not going to write sine theta. Okay, we are actually going to write cos theta because that's following the rules. Okay, if reducing sine or cos with 90 or 270, then we change sine to cos or cos to sine, and that's exactly what I've done here. We are reducing sine with 90. Okay, since whenever we do that, I'm changing sine to cos. However, you will notice that the mathematical sign, the positive or negative, that is determined by the first trigonometric ratio, not the second, because the second one is cos. I changed it to cos. The first one was sine. Okay, so whether I got a positive or a negative was actually determined whether sign was positive in this quadrant. Okay, it's easy to confuse it and look and think that, oh, 90 plus is in the second quadrant, so cos is supposed to be negative in the second quadrant. But that's not the case, because we look at the first one. Always look at the first trigonometric ratio to determine the mathematical sign. Let's look at the next example. We have cos 270 plus theta. Cos 270 plus theta. So again, the first thing we should actually notice is that we're working with cos and 270. Okay, since we're working with cos and 270, we need to remember the ruling. If reducing sine or cos with 90 or 270, then change sine to cos or cos to sine. So in this case, I know that my answer is going to have a sign, but I need to determine, it's going to have the sign trig ratio, but I need to determine the mathematical sign. Do I need to have a negative or do I need to have a positive? That's easy to determine. We just have our little cast diagram. And we can see that 270 plus is actually in the fourth quadrant. Okay, and the fourth quadrant cos is positive, so I'm going to have positive. Okay, obviously you don't have to write the positive. I'm just writing it so that we are aware. And then thereafter, I'm going to write what? Sine. Theta. Sine, and whatever the angle is, that's remaining. Okay, so cos changed to sine, and this angle stayed the same. Let's have a look at sine 270 plus. So sine 270 plus, firstly, we notice that we're using sine in 270, so you need to follow the ruling. Thereafter, you determine the mathematical sign. So 270 plus, again, is in the fourth quadrant where cos is positive. So sine is negative. Okay, since sine is, okay, so sine is negative. We use the first trig ratio to determine the mathematical sign that we use. Okay, and again, then we use the ruling of 90 to 270 to change sine into cos. So again, you don't confuse 270 plus, you're thinking how? Cos is positive in 270 plus. We use the first trig ratio to determine the positive or negative. Okay. Okay, so 90, 270 done. Let's talk about negative angles and the identities of negative angles. So this is simple, okay? How do you work with negative angles? So let's just say you had to have sine x. Sorry, sine negative x. So with sine and tan, okay, with sine and tan, you simply take those negatives out to the front. And it becomes negative sine x and negative tangent x. So sine negative x, so you have a negative angle, becomes negative sine x. And tangent negative x, you have a negative angle inside, becomes negative tangent x. However, with cos, it is different. Cos, we say, eats the negative or swallows the negative for you to remember, right? So cos negative x becomes just cos x, okay? It eats that negative. So cos x is the same thing as saying cos negative x. Okay, you don't get a different value. Okay, so how do negative angles work? So yes, in this case, it's simple because you have sine negative x and then you just take the negative outside. Okay, and you get sine x. All right. But how do we actually apply them? If we look at sine x minus 180, this next example, what's different about this? Because there is something slightly different about it. Okay, what's different about it and crucial is the fact that we have a negative reduction angle. The angle that we were reducing with, which is 180, is negative. So this is negative 180. This is incorrect. We cannot have a negative angle. This must always be positive. Should always be positive. Okay, and when we have a negative, it's an issue and we cannot reduce. Okay, so what we do in order to help us is we actually try to make that positive, okay, by taking a negative bracket. So let's do that. So I have sine. I take a negative bracket. So I take a negative, I divide it by -1. I am left with negative x plus 180. Okay, so I haven't changed the value of anything. Okay, because I haven't changed the value of anything, because if I multiply out this bracket, I will still get x minus 180. Okay, so just keep that in mind. Yes, when you multiply out that bracket, you get the same thing. And yes, now in this case, we are placed in a position where we have this negative outside the bracket, and how we can see this negative is almost like we have negative, and like we don't care what's inside there, that could be y. So it's almost like we have negative sine negative y. And if we have a negative angle, we know for sine, we can just take the negative out. So sine negative y, this is equal to negative sine y. Okay, so let's work with this example actually. And essentially, because we have negative and whatever the angle is inside, okay, I can take this negative out, negative sine, negative x plus 180. And now our reduction angle is positive, by the way. That's why we take out that negative bracket to make the reduction angle positive. Taking out the negative, if something's a negative and you divide it by -1, it's going to make it positive. Okay. And yes, now I'm just going to rearrange this so that it works with a way that makes more sense to us. Negative sine 180 minus x. Okay, so I hope that makes sense. All right. So as grade 12s, okay, here's the good news. You can skip directly from this step to that step. You don't have to show all the steps in between. Not at all. And I don't recommend you show the steps. It's a waste of time. You go straight from the first step to the second. I just did all the steps to explain it to you. Okay. So all of this you should skip. Okay. So, but now you understand how it works. If maybe you've learned to skip it already and go to the end, now you perhaps understand how it works and how do you get that. Okay. So let's do this example and we're going to skip. Okay. So let's analyze what we did. We had sine x minus 180, where our reduction angle was negative 180. We went from that to what? 180 minus x. So we made our reduction angle positive, and in turn, we had to make this negative, okay? And we took a negative bracket, and then that negative went out. So all of that can be just understood in one step. Since it is tangent, I can flip these, because when I flip them, remember, when you times something by a negative, it changes all the signs. So this would become a negative and this would become a positive. They all become opposite to what they were. So I have negative, because I'm going to simplify it, negative, okay, tangent, and inside the bracket, I shouldn't have x minus 180. I need to flip it. I need to have a positive 360 and a negative x, and automatically I also put my reduction angle in front one time. All of that in one step. Done. That is your issue with a negative reduction angle sorted out. Okay, let's do one with cos. And the reason we have to do one with cos is because, remember, cos swallows that negative. So here we took a negative and then we flipped inside the bracket. So here we do not do that, even though I'm doing it now. Minus x, because cos swallows this negative. So it doesn't even exist. Okay, so yes, cos x minus 270 is the same thing as cos 270 minus x. Okay, so now let's just reduce all of them to deal with two negatives. So I have 180 minus, again, I can't live without my cast. So I'm going to get me a cast diagram. 180 minus is where sine is positive. However, there's already a negative that exists here, so the negative stays. But we don't get the double negative. It's just negative sine x. So the reduction made it positive, but there's already a pre-existing negative here. So that just stays behind. Okay, then let's reduce this guy. Cast diagram. Okay, so this is equal to 360 minus is in the fourth quadrant where cos is positive. So actually tangent is negative in the 360 minus quadrant. So it actually becomes negative times negative tangent x, because 360 minus we simplify. And then this becomes tangent x, positive tangent x. Okay. And then in this case, again, first thing to note that you're working with cos and 270. It can be tricky, even if you practice the hard examples and you're comfortable with it. Sometimes you can just forget that, and then you forget to change it to sine, and you write cos. It can be an issue. Okay, but it does come with practice. So in this case, I first noticed that it's cos and 270. That means, okay, I need to change to sine. But now I need to work out which quadrant I'm in, so I can determine my positive or negative. So 270 minus is in the third quadrant where tangent is positive, so this becomes negative, but it doesn't become cos, it becomes negative sine x. Okay, I hope that is making sense. Let's look at two other rules, or two other issues, let's call it that. All right, what happens when we deal with angles that are larger than 360 degrees? Okay, so like a reduction angle that's larger than 360 degrees. So just say we have sine 720 minus x. Sine 720 minus x. So when we have these angles, we subtract 360, or if when you subtract 360, it's still larger than 360, then you need to subtract 720. And if it's larger than 720, 720 plus 360 is 980, I think. 720 plus 360. No, 1080, sorry. 1080. So then just say it's bigger than 1080, you subtract 1080. So basically, if it's bigger than 360, you subtract 360. If it's bigger than 720, you subtract 720. The 720 is twice of 360. So it's like two 360s. And then if it's even bigger, then you subtract 1080, but you're probably not going to get that example. So let's look at this case. We have sine 720 minus x. Okay, 720 is bigger than 360, so we can just minus 360. You don't even have to show the step, but 720 minus 360 is equal to 360 minus x. So now this is something we're a bit more comfortable using. Okay, then we can reduce this with our little cast diagram, where 360 minus is in the fourth quadrant, so this changes to negative sine x. I don't change the sign to cos, okay? I don't always do that because I'm working with 360. I'm not working with 90 or 270. I only change sign to cos and cos to sine when I'm working with 90 or 270, okay? So I get negative sine x because it's only cos is positive in that quadrant. So let's have a look at the next example. Cos 810 plus x, this is bigger than 720. So I'm going to minus, basically I'm minusing 360 twice, because if I minus 360 the first time, it's still going to be bigger than 360. Then I have to minus it again. So when I say 810, sorry, minus 720, we get cos 90 plus x. Again, you're not changing the value of anything here. This is all fine. Cos 90 plus x. And then how do I reduce this? I reduce this by keeping in mind that I have cos and 90. So I need to keep in mind that rule. Yeah, okay. However, remember that the sine is determined by the first trig ratio. So the sine is going to be determined by cos. So cos 90 plus is actually where sine is positive. So that's not good. That makes cos negative. So this becomes negative. But because we're working with 90 and cos needs to change to sine, negative sine x. So that's how we deal with angles larger than 360. I hope that makes sense. Let's have a look here. What happens when we deal with squared trig ratios? What happens when we deal with squared trig ratios? So it says here, the reduction of a squared trigonometric ratio. So what is a squared trigonometric ratio? Like sine squared, cos squared x, or tan squared x, cannot make it negative. Okay, that's a bit of an informal way to put it, but I'll show it to you in an example. But basically, when you reduce a square, you're never going to get a negative answer. So let's look at this, all right? Again, little cast diagram. You'll see like 5 million of these. Sine squared 180 plus theta. So 180 plus, okay, is in the third quadrant, and sine is actually negative in the third quadrant. Only tangent is positive there. So sine, so you might think this answer is supposed to be negative sine theta, but because it's squared, no matter what the reduction is, this is always going to be sine squared theta, positive sine squared theta, always. No matter what the reduction is inside, whether the reduction makes it positive or negative, when it's square, your final answer is always just going to be positive. Okay, so you can, okay, then let's look at tangent. again, 180, we can draw it to see if tangent is positive there or not. Tangent squared 180 minus beta. That's in the second quadrant, but tangent is not positive there. So you would think you'd put a negative, but you actually don't because of that square. So this answer is just tangent squared beta. Okay. What about this answer? Okay. So what do we have? Cos 90 plus alpha is in the second quadrant. 90 plus alpha is in the second quadrant. Okay. So cos is negative in the second quadrant. However, that negative is coming from reduction. And whenever we have a squared term, the reduction will never make it negative. The reduction will never make that term negative when you reduce it because it's squared. So this, okay, this one has a few different things we need to note. Okay, so this inside of the bracket is not going to make it negative. So we're not going to get this extra negative in front. However, in our final answer, we are going to have a negative there because of this pre-existing negative. That pre-existing negative just means it's multiplied by -1. I can't just get rid of that. Okay. All we're saying is that from the reduction, we're not adding another negative because if we had to add, then it would become positive. Okay. Do you see that? But here, the -1 already exists before we reduced it. So therefore, that -1 stays. And in this case, our answer is not going to be cos squared alpha. Okay. Square is correct, but remember, we are working with cos 90. That's the first thing you should notice. We are working with cos 90, which changes it to sine. Okay, and then it's a squared term, so it's just sine squared alpha. Okay, so I hope that makes some sense. So let's do like 1 or 2 questions for reduction. So determine the value of the following without the use of a calculator. 6 marks. Okay, the best 6 marks you're going to get in your life. Tangent, okay, again, we don't survive without our little guy. Tangent 180 minus x. 180 minus is actually in the second quadrant, so that reduces to negative tangent x. Because it's in the second quadrant and only sine is positive there. Cos 360 plus x. So by the way, 360 plus is not... it can be depicted here in the cast diagram. 360 plus is the same as having 0 plus. Okay, obviously they're always indicated as 360 plus, but it's basically in the first quadrant because you're going back to the first quadrant. And in the first quadrant, all are positive. So this definitely remains positive. It just says cos x. Okay, then let's reduce the bottom. So don't be scared of this coefficient. The coefficient is just there. It's just a 2. Okay, then we have cos 90 plus. Okay, you need to be able to identify this immediately that you're working with cos and 90. Again, if you're working with sine 90, cos 90, just red flag. Okay, I need to do something extra here. So in this case, I determine which quadrant this is in, so I can get the mathematical sign. And remember, when you're changing from sine to cos or cos to sine, if you want to determine whether it's positive or negative, you will determine that from the first trig ratio. So before you change it, you determine the sign. So cos, I'm going to determine it with cos. Cos 90 plus. 90 plus is where sine is positive. So I have to use the sign that I'm getting from the first trig ratio. So in 90 plus, only sine is positive. So this actually becomes -2. And then right, it becomes negative. The term becomes negative, so negative cos and then -2. And then cos 90 plus x. So 90 plus cos 90, that's an exception, meaning I have to change from cos to sine, keep the angle the same. Okay. So I hope this is making sense so far. This is reduction. Okay, we can simplify further. That's why we need to get 6 marks. We haven't completely done the things to solve this yet, but I trust most of you probably know it by now, or at least somewhat of it. But it's when we get to identities, right? We learn that tangent x, actually you should know this from previous grades, of course. Tangent x is equal to sine x over cos x. Okay, and that's what we're going to do. We're going to simplify this guy. We have negative sine x over cos x times cos x divided by, or I can even just multiply tip and times. So I'm going to multiply by tip and times. Currently we have negative 2 sine x over 1. So it becomes 1 over 2, 1 over negative 2 sine x. So in this case, anything in the numerator and the denominator which are common and are in multiplication can be cancelled. So here we have in division, multiplication, top and bottom. Basically, you can always calculate from top to bottom and vice versa, of course. And also, because it's all multiplication, this guy's on top, that guy's at the bottom. So sine x and sine x cancel, negative and negative cancel. And as you can see, they all leave 1 behind, by the way. Sine x divided by sine x is 1 and 1. And cos x divided by cos x is 1 and 1. So they all just multiplied by 1. That's why I don't write anything. But essentially now we're left with 1 over positive 1 over 2. Okay, that those negatives canceled. Okay, let's move on. Let's have a look at this. Given the expression, that, whatever that is, simplify the expression. Okay, I want you guys to try this. I'm going to give you guys like 2 minutes. Try this question, and then I'll do the answers. Okay, 7 marks. I'll give you like 2.5 minutes. Okay, don't do 6.3.2. We'll get there later on. But yeah, just reduce the top. Okay, 3 minutes. Let's just say. Answer. That's the answer. Okay. And I'll be back shortly. Okay, it's almost 44. Let me continue with this answer. 6.3.1. So, So we have cos 180 plus k. So here's my cast. Okay. 180 minus, sorry, cos 180 minus is in the second quadrant where sine is positive. So this gives us therefore negative cos k. Okay. Why? Because 180 minus sine is positive there, cos is negative. So negative cos k. Then we have sine k minus 90. Okay. Now the issue here is that we have this negative reduction angle. We do not want a negative reduction angle. We need to make that positive. So if you remember the shortcut, don't worry about reducing everything in one step. Okay. Take that little bit extra step to make sure you just understand everything and everything is correct. So sine k minus 90 would become negative sine 90 minus k. Swap what's in the brackets and make it negative. Negative sine 90 minus k, and then we have this minus 1. Okay. And then let's look at the bottom. We have tangent squared 540 plus k. 540 is bigger than 360, so I'm going to minus 360. And this becomes tangent squared 540 minus 360. 180, that's more what we used to. Plus k, we'll reduce that in the next step. Then we have sine 90 plus k, sine 90 plus k. So firstly, you should notice sine and 90. Secondly, you need to see it's 90 plus. So 90 plus is where sine is positive, and our first trig ratio is sine. So we're going to keep a sign. It's going to be positive, right? I'm not going to put anything because positive, or you can leave it blank. It doesn't matter. Especially when it's the first term of an expression, then of course you don't need to put the positive. Okay. So it changes to positive. 90 plus. Okay. Yeah. So since we're working with sine and 90. Okay. Sorry. Since we're working with sine and 90, it's going to change to cos. So it's going to be positive cos k. Why is it positive? Because sine is positive in 90 plus. Then we have, this is interesting, cos negative k. Remember, okay, so we have a negative angle. Again, inside of the brackets, we have a negative angle. So all we have to do is take it out, except when it's cos. Cos swallows that negative. So let's just say this cos k doesn't change. Okay, let's look at the next example. Sorry, let's look at the next step. So negative cos k. Okay, you can even start canceling now, but let's not for now. Let's just leave it. Okay, let's sort this guy out. So we have negative sine 90 minus k. So firstly, we have sine and 90. Sine and 90 means I'm going to change it to cos. Then I look, okay, I have 90 minus. 90 minus is actually in the first quadrant where everything is positive. So the reduction of this term gives me a positive. I already have an existing negative there. So my answer is simply going to be negative. Change sine to cos. Cos k minus 1. Divided by, now I can reduce this guy as well, tangent squared 180 plus k, tangent squared 180 plus k. Let's reduce that. Okay, so 180 plus, either way tangent is positive there, but remember it didn't matter because of the square. Okay, either way, no matter what, this was going to become tangent squared k times, we're going to have here at the bottom cos squared k if we want to simplify that. Okay, and then the top we actually can simplify. Negative cos k times negative cos k is actually positive cos squared k minus 1 divided by, let's see what we can do at the bottom, sine squared k over cos squared k times cos squared k. Inside of the denominator, in the denominator of this term, okay, cos squared k is the same as a term in the numerator. All multiplication, by the way, there's no additions here at the bottom, just at the bottom, there's no additions. We only do this easy canceling across multiplication or division only, okay? And we left with, so for now, we're not going to simplify it completely just because we haven't gotten to identities yet. But for now, we'll keep this as cos squared k minus 1 divided by sine squared k. I'm sure many of you know how to solve this anyway. It's Just one more step, but we won't tackle it now. We'll tackle it when we do identities. Okay. Cool. So I hope that makes sense. I hope you guys understand reduction well or better or for the first time. Okay. Next week, we shall continue reciprocals, special angles, just some basic revision still. Move on to Cartesian plane questions, probably end there next week. And the following week, do in terms of questions, and then get to trig identities, general solution, and all that good stuff. Okay. So I hope you guys enjoyed. Thank you guys so much for joining. I hope that it was beneficial and that you understood. I'm going to leave it open for the next 2 minutes to see if there's any questions. Otherwise, I'll just automatically end it. So for now, thank you guys so much for joining. Jazakallah khair. Assalamu alaikum and goodbye. Again, please remember, if you do have any questions, stay behind and ask some questions. If not, the session will end.